All right, let's talk about system design. It sounds complicated, right? Well, today we're going to pull back the curtain on this really cool field by following one simple action, a single click, on its incredible journey through the digital world. Let's get into it.
Think about it. You do this a dozen, maybe 100 times a day. You type out a thought, you upload a picture, and you smack that post button. It feels instantaneous, doesn't it? But in that tiny fraction of a second, a whole universe of tech just explodes into action. So what is actually happening behind that screen?
So that's what we're going to do. We're going on an adventure. We're going to follow that one little click from the tip of your finger across the vastness of the internet, through these massive, humming data centers, and all the way back. And by the end of it, you'll have a map, a real blueprint of how the modern web actually works.
Okay, so before we kick off this journey, let's get on the same page. What even is system design? You can think of it as the master plan, the architectural blueprint for pretty much any digital service you use every day.
You know, the best way to think about it is like building a skyscraper. You wouldn't just start throwing bricks and steel together, right? Of course not. You'd need a detailed blueprint, one that lays out the foundation, the structure, the plumbing, everything. Well, system design is exactly that, but for the software world. It's the plan that makes sure the whole thing is strong, efficient, and doesn't just, fall over when a million people show up at once.
Okay, here we go. Our click has just left the building. Your phone or your computer, that is. Its very first challenge? It has to navigate the massive, chaotic, sprawling network of the internet to find its destination. This is where networking protocols come in. They're basically the traffic laws of the internet.
And right off the bat, our click has a choice to make. Is it going to travel via TCP? That's the reliable path. Think of it like sending a package with a tracking number. You know for sure it's going to get there and all in one piece. Or will it use UDP, the fast path? That's more like chucking a handful of postcards over a fence. Super fast, yeah, but hey, some might not make it. Since we're posting something, we can't afford to lose any of it. So our click, it's going to take the reliable route, TCP.
But wait, how does it know where it's even going? It needs an address, an IP address. And this is a great illustration of a massive problem we had to solve. The old system, IPv4, was like a small town with a limited number of street addresses. And guess what? We totally ran out. So we built IPv6. This isn't just a bigger city, it's practically an infinite city, with enough addresses to give one to, well, pretty much every grain of sand on Earth. It's a mind-boggling number. And our click is headed to one of them.
Okay, so our click made it. It's navigated the Wild West of the internet and has arrived at its destination. But here's the thing. It's not the only one. It's showing up with literally millions of other requests at the very same moment. So how does the system handle that kind of massive crowd without just collapsing? It builds a very, very orderly pathway.
So a click can't just storm the front gates. No, it has to follow this super organized path. First, it stops by the local CDN, kind of like a neighborhood convenience store, to grab stuff like images really fast. Then it gets to the reverse proxy. Think of this as the bouncer at the front door checking its ID. Next up, the load balancer. This is the traffic cop, pointing our click to an open lane, to the server that's not swamped. And finally, it hits the API gateway. This is like the main receptionist who knows exactly which department to send our post request to.
All right, our click is in the door, it's been checked, routed, and sent to the right place. Now comes the real heart of the matter, dealing with the data itself. Where is your post actually going to be stored? And how can your friends pull it up instantly just a second later?
Now the system needs to decide where to file this thing. Is it going into a relational database, like a super tidy spreadsheet where everything has a specific box it has to fit into? Or does it go into a NoSQL database? This is more like a flexible folder. You can toss in text, photos, tags, and if they add a new poll feature next week, you can toss that in too. For something like a social media post, that flexibility is a huge win.
And here's the cool part. NoSQL isn't just one thing. It's like a whole family of different tools. A big system might use a document database to store the actual content of the post, but then use a totally different graph database just to map out all the friendships and connections so it knows who to show that post to. It's all about picking the absolute best tool for that specific task.
Okay, the post is safely stored away. But what if it goes viral? What if a million people want to see it right now? You can't have the system digging it out of the main file cabinet every single time. This is where caching is a lifesaver. Seriously, just think of it as the system's short-term memory.
It keeps the hottest, most popular posts in this super fast lane, ready to be served up instantly, without breaking a sweat. So, that whole process, it works perfectly for our one little click. But how in the world do you go from that to handling billions of users all around the globe? This is the ultimate challenge: scalability.
Well, there are really two main ways to grow, and the robot analogy here is perfect. You can scale vertically. That's like building one massive, super powerful giant robot. It's simple, sure, but it's expensive, and if that one robot goes down, well, your whole operation is toast. Or you can scale horizontally. This is like building an army of smaller, cheaper robots. It's way more complex to manage, yeah, but if one robot breaks, the rest of the army just picks up the slack. This is how the big guys do it.
But once you have that army of servers spread all over the world, you run into this fundamental law of physics for distributed systems. It's called the CAP theorem, and it forces you to make a really tough choice. Do you want perfect consistency, meaning everyone, everywhere sees the exact same thing at the exact same time? Or do you want availability, meaning the site is always online, even if some people are seeing data that's a few seconds out of date? You can't guarantee both when things go wrong. A bank, it has to choose consistency, no question. But for a social media site, they'll pick availability almost every single time, because seeing a slightly old post is way better than seeing the big error page.
And just like that, our Click's incredible journey is over. It's been routed, processed, stored, and made ready for a global audience. So let's step back for a second and look at the big lessons we learned along the way.
Here's the #1 takeaway from all of this, and it's really important. System design isn't about finding the one best tool or the perfect technology. It's never that simple. It's a constant balancing act, a series of really smart trade-offs. At every single step, we saw a choice being made: speed versus reliability, consistency versus availability, simplicity versus scale.
And this quote right here just nails it. The right answer in system design is always, it depends. It depends on what you're building. What's right for a bank is totally wrong for a video game, which is totally different from what's right for a social network. Context is absolutely everything.
So we followed one tiny click through this massive, hidden world that's actually incredibly elegant when you see how it all fits together. We've seen how all these layers of thoughtful design make our digital lives possible. These principles, they're not some kind of dark magic anymore. So now that you have the blueprint, the real question is, what amazing thing are you going to design?